Good morning, Blackmates, and to you, Ma'am Marshall Matulak. I am Mika Bakalangko, and for this topic, I will tackle about the life, works, and contribution of Madhava of Sangamagrama. And for the presentation outline, first, I am going to introduce Madhava, and then I will give a brief explanation about his works and contribution in the field of mathematics and astronomy. And lastly, at the end of this presentation, you can see all my references. So let's start. Who is Madhava or sino nga ba si Madhava of Sangamagrama? So he was an Indian mathematician and astronomer who lived in the 14th century, and he was born in the Indian state of Kerala from the town of Sangamagrama in 1350 and died in 1425. Ang present Ngayong present day, ang pangalan na ng Sangamagrama is Irinjalakuda near Thrissur, Kerala, India. So he was the greatest mathematician astronomer of medieval India, and he is also famous for founding the Kerala School of Astronomy and Mathematics in Kerala, India. So itong school na finound niya is very well-known school because Madhava led to many intelligent minds onto the path of new discoveries. So this school ran for about 2 centuries after Madhava, and it brought forth many researchers and discoveries in the field of mathematics and astronomy, and also in the field of linguistics. So did you know that almost all of Madhava's work is lost? Meron namang nakasurvive at isa dito yung Golavid, which means one who knows the sphere in Sanskrit. So isa yan sa mga nakasurvive na work ni Madhava. So next is that he also discovered a procedure or pamamaraan on how to determine the positions of the moon every 36 minutes, and he also discovered the methods to estimate the motions or ang galaw ng bawat planeta. So Madhava has very less known about his early education, but his contributions in mathematics and astronomy are still widely acknowledged. So many of the mathematicians who came after him worked further on his discoveries and have been found to refer to him and acknowledge his work in their publications and on their own research. So now let's talk about his famous work, which is the uh, obtaining the value of pi, in which he used infinite series. So, recap lang, infinite series are the sum of infinitely many numbers related in a given way and listed in a given order. So, he obtained a value for pi correct to an astonishing 13 decimal places. So he went further, linked the idea of an infinite series with trigo. So he realized that, as you can see sa picture, by successively adding and subtracting different odd number fractions to infinity. So sa formula ni Madhava, pi is equals to 4 minus 4 third plus 4 fifth, so on and so forth. So in this way, he could home in on an exact formula for pi. So after 2 centuries, si Leibniz, isang mathematician rin, same rin sila ng conclusion ni Madhava. So through this application of him, he obtained a value for pi correct to an astonishing 13 decimal places. Tapos, ito yung value ng pi, 3.1415926535897 if hindi i-round off. Pero kung i-round off na, yung 7 will turn into 8. So, ang value ng pi is in 13 decimal places is 3.1415926535898. So, due to its discovery by Gregory in 1671 and later by Leibniz. Both mathematician yan sila dalawa. So si Leibniz in 1676. This formula is also known as the Madhava-Newton series, Madhava-Leibniz series, Leibniz formula for pi, or Leibniz-Gregory-Madhava series. So ito yung series na dinerive niya, no, and he proved. This is the Madhava sine series or power series for sine, Madhava cosine series or power series for cosine, Madhava Gregory series or Gregory Madhava series or power series for inverse tangents, and Madhava's formula for pi, obtained by expansion of power series for inverse tangent. So next is we're going to talk about his contributions in these fields. So sa trigo, his contribution is by constructing the table of sines. He constructed the table of sines. He applied his infinite series in trigonometry, as well as he gave trigonometric sine values corresponding to 24 angles that represented equal intervals in a circle. Tapos sa field ng calculus, so Madhava took some results of the earlier mathematicians and worked on them. So many of his results form basis or foundation for the prominent future in developing calculus. So in the field of algebra naman, ito yon yung mga na-contribute niya, the rational fractions of pi, the polynomial expansion methods, the convergence of infinite series, infinite continued fractions, use of iteration to solve transcendental equations, use of continued fractions for approximation of transcendental numbers. So yan yung mga na-contribute niya sa trigo, sa calculus, and then sa algebra. So many mathematicians are of the opinion that ang mga gawa ni Madhava and other teachers or other mathematicians from his school, which is the Kerala school, got transferred to Europe because of the Jesuit missionaries and traders who were very active in that region of India in the 14th and 15th centuries. So that would be all. Thank you for listening.